Let's talk about how fossils can tell us some really interesting information about what our Earth used to look like a long time ago. So in this image, I'm looking at three different dig sites. So imagine I'm standing on the ground and I dig down through these layers of Earth. And I do that at three different locations. And in fact, I'm doing that on three different continents. You'll notice that there's an ocean in between these three layers of fossils. So let's talk about some basics first. One thing I know right away is that the oldest fossils are going to be in the deepest layers. Again, the deeper down you go, the older the fossil is. On the flip side, I know that the fossils near the surface are going to be the youngest fossils. So for example, the T-Rex and this Triceratops are going to be younger than this plant and this Stegosaurus. I can also tell how long things lived. In general, each layer of dirt represents several million years of time. So again, here, T-Rex lived for a shorter period of time than this plant because this plant is in more layers. If it's in more layers, it must have lived longer. Finally, we get to the interactions. I can see that since T-Rex and Triceratops are in the same location, they're on the same continent, and because they're in the same layer, I know that it's possible that T-Rex fought and possibly ate Triceratops, and indeed that's true. However, I can see that T-Rex and Stegosaurus are in different layers of Earth. What that tells me is that they did not live at the same time. Therefore, a T-Rex never fought nor ate a Stegosaurus. And again, this is true. These two dinosaurs did not live at the same time, so they never interacted. Finally, we can see interactions across continents. So I look at the T-Rex, and I look at sort of the sauropod on the side, and I can hypothesize that these two dinosaurs never interacted either. The T-Rex lived on this continent, and the sauropod lived on this continent. There was no interaction there. Going down a layer, I could probably tell that this Stegosaurus may have eaten this plant. They were in the same place and at the same time. I know that they're at the same time because they're in the same layer. Now, the final more interesting thing, especially when it comes to the idea of continental drift, is looking at fossils across continents. So let's look at the middle one and the one on the right. As I'm looking through the layers, in this first layer, I notice I have three different types of dinosaurs. And that makes sense. They're on different continents, so they probably have different animals. Just like right now, you can't go outside and see a lion. Lions are in Africa, and there's a big ocean between us. Same thing in prehistoric times. There was an ocean between these dinosaurs. Going down a layer, in this middle layer, I still see that there's no similarities. The plants in the example on the right are different than the plants on the one in the middle. Again, if you went to Africa or Asia right now, you would see plants that are different than the ones you see outside. We're on different continents, so we have different plants and animals. Now, a more interesting thing is when there are similarities. So let's take a look at the left sample and the middle sample. Right away, I see that T-Rex is in the left sample and T-Rex is in the middle sample. Now that should make your eyebrows go up. T-Rex had tiny little arms, strong legs, was very good at running, but it certainly wasn't swimming. And there's no possible way a T-Rex could swim across an ocean. Interesting. Same thing for Stegosaurus. Stegosaurus weighed several tons. There's no possible way that a Stegosaurus could have swam across the ocean and died and become a fossil on a different continent. Even more interesting are the plants. Plants don't fly or swim, so how could a plant from one continent become a fossil in another continent? Well, according to Wagner, the most obvious solution was that these two continents weren't always split apart. He would hypothesize that at one time, long time ago, that these continents, in fact, were together, that there was no ocean in between them. And now this starts to make sense. If these continents were stuck together, it would make sense that I would see T-Rex fossils on both locations, because T-Rex could have walked across the surface anywhere as these two continents were connected. They could have died and become fossils. It would also make sense for these earlier fossils. Stegosaurus could have lived on both of these. They could have died and become fossils. Wagner would then go on to say that once these fossils were in the ground, then the continents split apart. So that these bones that were buried in the dirt, they stayed in that continent as it drifted apart from the other continent. And that explains why we can have fossils that match on two continents, even though there's an ocean in between them.